All right, so this first one is a cubic function, so it's going to be that wiggly shape. And it moved left 4 and down 1. So I'm going to go left 4, down 1, put a point. And then I would like some points on either side of that. So I'm going to, here's my, guess I'm going to struggle with that here. I'm trying to use a transparency over this so that I don't have to waste more paper, and because I have to do this 4 times with each of my classes. So we'll see how this goes. I want some more points to plot, so I'm going to make an XY table. This point is at -4, so I'm just going to try some numbers that are near -4. So I'm going to do -5 and -3, and we'll just see what we get. So -5 plus 4 would be -1, cubed would be -1, -1 would give me -2. And if I plug in -3, this part's going to be 1, cubed would be 1, and then -1 would be 0. So that is going to give me points here and here. And it looks linear, but you just need to remember that it is the cubic graph, and so draw it in as a wiggly shape. All right, your LN graph, that's going to be this sideways swoopy kind of shape. This one moved right 2. So I'm going to dot in the asymptote at 2. And if you just drew it in like this, that's fine. If you do want another point, let me go over this because I don't think I hit this hard enough in class. Ln and e to the x are inverses of each other. Do you remember when we did e to the x, the only number we could plug in without a calculator was 0. E to the 0 is going to be 1. So if you plug in 0, you get 1. Ln is just the reverse of that. If you plug in 1, you get 0. And those are the only ones that you can do without a calculator. So what number would we have to plug in for x in order to make this be ln of 1 so that we can get 0? What x would we have to plug in here? All right, good. I saw somebody type 3. Nice job, Ethan. All right, so 3, and then 3 minus 2 would be 1, and ln of 1 would be 0. So if you want one specific point, it's going to be right there, 3, 0. And the graph is going to do something like that. All right, this is your step function, that greatest integer function, and it is moved up 2. I'm going to space this out a little bit because otherwise the steps are going to be teensy tiny. I'm going to count this as 1 unit just so that we can see it a little bit better. So we're going to, instead of starting at the origin, move up 2. So I'll have a point here. I'm going to stay on that step until I get to 1, and then I will move up to the next step. And so you have this infinite staircase here. Sorry, those two are open circles. It was on the axes, so kind of hard to see. There we go. All right, this graph is the rational function that's moved left 3. Or you could think of it as the vertical asymptote needs to be at -3 because that's what makes the denominator 0. And then when we go to get the horizontal asymptote, we have to compare the powers of the function. In the numerator, there's no x at all, so that's x to the nothing. And then in the denominator, that's x to the first. So if the numerator is smaller than the denominator, it is automatically 0. So this is going to level off at 0. And then I just need to know where to put the arms of the graph. They're either going to be up here or down here. And we can just pick some points to plot to see where they go. I'm going to pick a number that's in this section. So let me try -4. -4 plus 3 would be -1. 1 over -1 would just be -1. So that point will be here, and that tells me that this arm of the graph has to be coasting along down here. And then I'm going to try -2. -2 plus 3 would be 1. 1 over 1 is 1. So that is going to be right here, and this arm of the graph will be like that. All right, questions before I go to the other two, because I have those on a separate page. I'm going to erase all this, so if you have a question, let me know now. right, so here is our other rational function. We are going to have to factor this. So the numerator, the 3x squared, is going to split 3x and 1x. And then the 3 is going to be 1 and 3. And to get a positive 8 in the middle, we would need positive 9 minus 1. So plus here, minus here. All right, denominator is going to split 5 and 3. And to get a negative 2, we would need a negative 5 plus 3. So since we have these factors that are going to cancel out, what does that mean we get in our graph? All right, good. There's going to be a hole in the graph. And where is it going to be? Since x plus 3 is what cancels out, where is the hole going to be? All right, good. Negative 3. Thank you, guys. All right, so negative 3. And I'm going to take that negative 3 and plug it back into what's left here. I'm pretty sure this comes out to a fraction, but let's see what we get. This would be negative 9 minus 1. That'd be negative 10. And then negative 3 minus 5 would be negative 8. Okay, so those negatives are going to cancel, and 10/8 would be 5/4, or 1 and a 4th. So that is going to be like right about there, like just a little bit above 1. Good enough. And then we are going to do the asymptotes. So the vertical asymptote will be, goodness gracious. The vertical asymptote is going to be at 5, since that is what makes this denominator 0. And then horizontal asymptote, you have to come back here and compare the powers. They're the same, which means we're going to use the leading coefficients, which are 3 over 1, which would be 3. So this is going to level off at 3 on each side. And then I can kind of connect to this hole that I have here, and graph will do something like that. And of course, if you wanted more points, just make an XY table and you can get more points. And then here's our piecewise function. The domain is splitting at 1. So I'm going to just try to plug in 1 for this first piece of the function. What kind of circle is 1 going to get for the first piece of the function? All right, perfect. That'll be closed because we've got the equal to. So if I plug in 1, 1 plus 2 will be 3, squared is 9. So I get a closed circle at 1, 9. Will be right there. And then I need to plug in some numbers smaller than 1. So let me try 0. 0 plus 2 would be 2, squared would be 4. And let me just try a few more. Again, I have to go to the left. This is all numbers smaller than 1. So if I do negative 1, that will give me 1. If I do negative 2, that'll give me 0. Oh, I think that's the center. I'm trying to get to the center here. If I do negative 3, that'll give me negative 1 squared, which would be 1. And there, see, I found where it turned around. So 0, 4, negative 1, 1, negative 2, 0, so on and so forth. And so you just get this piece of the parabola. It just gets cut off there, so we don't get the other side of it. And then 5 is just a constant function. That's just going to be a flat line at 5. Just instead of the whole way across, we only want it from 1 onwards. And we will put an open circle there. So open circle at 1, 5, and then it will continue like that. So is this function, and I'm not going to grade your spelling when you type it in the chat, okay, is this function continuous or discontinuous? Sweet, discontinuous. Nice job, guys. And we are going to talk about continuity a lot today.